Assalamualaikum and a very good day to Dr. Noaini and everyone. We are Group 4 from SIC 1004 Physical Chemistry 1. Before we begin, let's think about two big problems our world is facing today: climate change and finding safe, clean energy for the future. How can we power our world in a way that is clean, efficient and continuous? One of the answers lies in electrochemistry, specifically the technology in the topic of our presentation today, fuel cells. In this presentation, we will guide you through the whole idea of fuel cells. We will cover a simple introduction, what fuel cells are and why they matter. Next, the principle of operation, how the chemical reaction actually produce electricity. Then, the different types of fuel cells, followed by their advantages and challenges they still face. Finally, we will look at real-life applications and the current and future developments of this technology. My name is Aliyah Naziha, and these are the members who will be presenting with me today. We are excited to explain this technology and help everyone understand how fuel cell works. Now, let's go to the introduction. A fuel cell is basically a clean energy device that turns chemical energy straight into electrical energy. It does not use fire or combustion like normal engines. Inputs of fuel cells are simple. Hydrogen goes into the anode and oxygen goes into the cathode. These two react in a controlled, clean way to produce an electric current that can power a device. Why is this important? Because this reaction is extremely clean. Since nothing is burned, the main output is only water and a small amount of heat. This makes fuel cells a very promising technology for reducing pollution and supporting a sustainable future. If you look at the diagram on the slide, you'll see that fuel cells has three main parts. First, the anode, where hydrogen enters and gets split. Second, the cathode, where oxygen enters. The third one, the electrolyte, the membrane that allows hydrogen ion to move from the anode to the cathode. These parts work together to ensure the electrons are forced to travel around the external circuit, and that movement of electrons is what produces electricity. To understand exactly how hydrogen splits and combines with oxygen, let's move on to the principle of operation.
Principle of operation. The first one is oxidation at the anode, which is in the fuel side. The fuel, commonly hydrogen gas H2, will enter the anode. At the anode, hydrogen molecules are oxidized to the hydrogen ion and release the electron. The second one is electron flow in external circuit. Electron will flow through the external circuit and creating an electric current that will power the device. Ion conduction through the electrolyte. The electrolyte allows only ion, which is hydrogen ion, in proton exchange membrane fuel cells to pass through. The next one is reduction at the cathode, which is in oxygen side. So, the oxygen will undergo the reduction and combining with the electrons that from the external circuit and proton, which is from the electrolyte. So, we can see the cathode reaction, which is oxygen will produce the water molecule. And for the overall reaction, when hydrogen and oxygen combine through the controlled electrochemical steps, which is hydrogen combined with oxygen that release the water, electricity, and also the heat.
Okay, for my part, I will briefly explain the 6 types of fuel cell. First, proton exchange membrane fuel cell. Use a polymer membrane, operates at 50 to 100 degrees Celsius and use platinum with H+ ions. Is the most suitable and ideal for vehicle. And the next, solid oxide fuel cell. Use a solid ceramic electrolyte and works at very high temperature, 700 to 1000 degrees Celsius. It uses nickel and carries oxide ions. This one is mostly for industrial power generation. For molten carbonate fuel cell, the electrolyte is a molten carbonate submixture, so it needs 600 to 700 degrees Celsius. It also uses nickel and the carrier ion is carbonate. It is suitable for large-scale power plants. Then we have alkaline fuel cell, which use liquid gallium hydroxide and it operates between 60 to 200 degrees Celsius. It uses nickel and carries hydroxide ions, but it very sensitive to carbon dioxide. Next is phosphoric acid fuel cell, which contain liquid phosphoric acid as the electrolyte. It works at 150 to 200 degrees Celsius. Use platinum, carries H+ ions, and this type is reliable for buildings, lights, hospital. And the last one is photonic ceramic fuel cell, which use a ceramic photon conductor, operates at 400 degrees Celsius and 7 to 700 degrees Celsius. Use nickel-based catalyst and carries H+ ions. And it's an emerging technology with high efficiency. And then for the most suitable type of fuel cell for high temperature fuel cell is solid oxide fuel cell. For solid oxide fuel cell, it uses a solid ceramic electrolyte that only conducts oxygen ions effectively at very high heat. The high temperature also helps the fuel reforming process and make it ideal for industrial and stationary power. And then for the most suitable type for low temperature is the proton exchange membrane fuel cell. It uses polymer membrane that conducts proton, and this membrane works the best at low temperature. And it can start up quickly, it's safe, and it's very efficient at low heat.
Thank you, Afiq. Now, let's move straight into the advantages of fuel cells. First, high efficiency conversion rate. They are much better at turning fuel into useful energy than a typical gasoline engine. They do this directly through a chemical process, not by burning fuel. This wastes less energy, allowing fuel cells to be 60% efficient or more. This means we get much more power from the same amount of fuel. Second is zero emission for a healthier environment. When a fuel cell uses pure hydrogen, the only thing that comes out of the exhaust pipe is clean water vapor. This is crucial because it means zero harmful pollutants like nitrogen oxides, which cause smoke and breathing problems, and zero carbon dioxide, the gas that drives climate change. By using fuel cells, we are cleaning the air in our cities and protecting the planet. Third, it requires low maintenance. The main part of the fuel cells, the stack that makes the electricity, has no moving parts, unlike a combustion engine with piston and gears that wear out. A fuel cells run smoothly and quietly. This means less time and money spent on repairs and service. Next, long-range capability. This is crucial for competition with gasoline cars. You can drive a hydrogen fuel cell car hundreds of millions on one tank. Even better, refueling only takes about 5 minutes, just like a normal gas car. This long range and quick refueling make fuel cells the ideal choice for heavy-duty application like long-distance semi-trucks, train, and even ships. Finally, we have quiet operation. The chemical process that creates electricity in the cell stack is virtually silent. The only sound you might hear comes from fans that cool the system. This quiet nature is a huge benefit for providing backup power to hospitals, powering homes in quiet neighborhoods, or for military uses where silence is essential. Now I will pass to Azam.
Next, I will explain about 4 main challenges of fuel cell technology, which are high cost, durability issues, hydrogen storage, and sensitivity to impurities. First, fuel cells are still expensive. This is mainly because they use platinum as a catalyst. Platinum is rare and costly, and the other compounds such as membranes and bipolar plates also require advanced materials. This makes fuel cells more expensive than traditional engines. Second, fuel cell durability remains a major issue. Over time, the catalyst can degrade, the membrane can weaken, and the system can be damaged by temperature and humidity changes. This reduces performance and shorten lifespan, then affecting reliability. Third, hydrogen storage is challenging. As we know, hydrogen is highly flammable compound. Hydrogen also has very low energy density, so it must be stored at extremely high pressure at very low temperature or in heavy solid materials. All these methods are costly and require special safety measures. Finally, fuel cells are very sensitive to impurities. Even small amount of gases like carbon monoxide or sulfur compound can poison the catalyst and reduce performance. This means hydrogen must be purified at very high level, which increases the operating cost.
From the principle of operation, fuel cells produce electrical energy by combining hydrogen and oxygen. This electricity can be applied in several real-world applications such as transportation, stationary power and backup, and portable power systems. In transportation, vehicles powered by hydrogen are known as fuel cell vehicles. They typically use proton exchange membrane fuel cells which are lightweight and efficient, making them suitable for cars, buses, and trucks. A real-world example is the Toyota Mirai, a commercially available hydrogen car operating in Japan, the US, and Europe. This vehicle offers several advantages. They produce only water vapor, making them true zero-emission vehicle. They can travel approximately 300 miles per refuel in just 3 to 5 minutes, which is much faster than charging electrical vehicle. Lastly, with an energy conversion efficiency of 50 to 60%, these vehicles provide a practical and sustainable solution for modern transportation. Next, stationary power and backup fuel cells provide a variable source of electricity for critical facilities such as hospital, military base, data center, and telecommunication infrastructure, helping them avoid downtime during power outage. This system deliver continuous power even when the grid fail, emit far fewer pollutants than conventional diesel or gas generator, and can generate both electricity and usable heat through combined heat and power system, improving efficiency and reduce waste. In real-world contents, companies like Bloom Energy offer this fuel cell system to industry including data center, biotech, and healthcare, allowing them to maintain energy independence while minimizing their carbon footprints. Finally, portable power fuel cell systems supply electricity for mobile or remote application, where conventional power systems like batteries or grid connection are unavailable. They are compact, lightweight, and can operate cleanly with zero emission, making them ideal for off-grid and emergency. A real-world example is PowerTrack, which uses hydrogen extracted from water to charge small devices such as phones, laptops, providing a convenient and sustainable energy solution on the go.
So now, I will be talking about the current and future development of fuel cell. As we all know, the most common type of fuel cell that is used today in transportation is the proton exchange membrane fuel cell, PEMFC. It's popular because it delivers high power density and responds quickly, which are important for vehicles. The components that made of PEMFC, such as membrane electrode assembly, diffusion layers, bipolar plates, and catalyst layers, are very important because they improve performance, lifetime, and bring down costs, which can enable more realistic and large-scale deployment of fuel cell. As for the future of fuel cell, we'll be looking towards more cheaper and better choices, such as the ceramic-based fuel cell like protonic ceramic fuel cell PCFC, and also solid oxide fuel cell SOFC that are now being developed, which could make fuel cells cheaper, more robust, and capable of using a wider range of fuel and not just pure hydrogen.
The conclusion for this study is fuel cells are a clean and efficient energy technology. This is because fuel cells convert chemical energy directly into electricity without combustion. They provide high efficiency with low emissions and quiet operation. Also, they require minimal mechanical parts, making them suitable for small to large-scale power applications. However, they face issues such as high cost and limited supporting infrastructure. They also must have high temperature cell endurance. These aspects are the major focus of manufacturers' technological efforts for fuel cells. With very low emissions of carbon dioxide and other reactive organic gases, they help reduce pollution because they produce very low harmful gases. Overall, fuel cells support SDGs by promoting clean and affordable energy, reducing air pollution for better health and climate action, and encouraging sustainable industry and innovation. That's all from us. Thank you.